Okay, in this lesson, we're just looking at a bunch of examples using the general integral rules discussed in the previous lesson. The first one is we're looking at the integral of 3 sine 2x dot dx. Now, it's really good practice in every one of these questions to take any constants and move them in front of the integral sign. So we're looking at 3 times the integral of sine 2x dot dx. So you want to, if you possibly can, to set it up so it resembles a rule. In this case, we're looking at the integral of sine, and we've got a linear factor that's 2x. So it will end up being 3 multiplied by 1 on a, which in this case is 1 on 2. Now, of course, the whole thing is negative because the integral of sine is negative cos. So 1 on 2 cos 2x plus c. So we end up with negative 3 on 2 cos 2x plus c. Okay, so a very simple integral there. When we look at the next question, we can take a similar approach. We can take that 5 out in front, and we've got 5 multiplied by the integral of cos negative 2x plus 3 with respect to x. So we've got 5 multiplied. Now the integral of cos is sine. We have to divide by the derivative of this bracket. So that's that 1 on a thing. So we've got 1 over negative 2 sine, and we keep our bracket the same, negative 2x plus 3 plus c. So we've got negative 5 on 2 sine negative 2x plus 3 plus c. So again, a nice simple integral, just following the rules that we've already learned in methods. When we look at example 3, it is an exponential. This is our internal function. So we've got 2 lots of the integral, e to the power of 5x plus 2 with respect to x, which means we've got 2 multiplied by 1 on a, which will be 1 on 5, e to the 5x plus 2. And don't forget Charlie. So we have 2/5 e to the power of 5x plus 2 plus c. So again, another nice, quick, simple integral. Now they should be really easy to follow like this. Now, in the other questions, you could be highlighting the internal function. It may help you with your process because remember, we're just dividing by the derivative of that internal function as long as it is a linear function. Okay, in this case, we've got 2 take x, which we could rewrite that as negative x plus 2 if that helps. So we've got 3 integral e to the negative x plus 2 with respect to x. And that means we've got 3 multiplied by 1 on negative 1, and then e to the negative x plus 2 plus c, and that comes out to be negative 3 e to the 2 take x. So I've just put that back in its original form, plus c. So again, a nice simple integral. Now, I'm hoping that everyone remembers this property. If we're finding the integral of multiple sums or differences, we just split them up. We're looking at 5 times the integral of x cubed with respect to x, 3 times the integral of x squared with respect to x, negative 2 times the integral of x with respect to x, and then we've got the integral of 5 with respect to x. Okay, so this becomes quite simple. We've got 5 x to the power of 4 on 4. We've got 3 x to the power of 3 on 3. We have 2 x to the power of 2 on 2, and 5x plus c. Now I just want you to keep in mind that these rules, and I know these ones are the ones that you've probably used most frequently so far, they only apply when we add 1 to the power and divide by the power, when the variable is the base. So if this variable is in the power, then we're going back to exponentials and so on. So this simplifies down to be 5 on 4 x to the power of 4 plus x cubed take x squared plus 5x plus c. So again, nice and simple. Now they get a little bit more complex, but we can still take the same approach. We can take this 4 out in front, and we've got the integral of 2x plus 1 to the power of 3 with respect to x. So remember, we're going to keep the brackets the same. We're going to add 1 to the power and divide by that power, but we're also going to divide by the derivative of this bracket. So this is a 1 on a component, so it will be 2 here, and don't forget Charlie. So these 4 cancel, and we end up with 1/2 2x plus 1 to the power of 4 plus c. Here we can treat this as 3x take 1 to the power of 1/2. And as soon as we do that, we can see it's the same approach. We add 1 to the power, we divide by a new power. So we've got 3x take 1 to the power of 3 on 2. We're dividing by 3 on 2, and we're multiplying by the derivative of this bracket. So that's the a component. So by 3 there, and don't forget Charlie. So now we've got 3x take 1 to the power of 3 on 2 over 9 on 2 plus c. Now if we're dividing by a fraction, we're multiplying it by its reciprocals. So we end up with 3x take 1 to the power of 3 on 2 on 9 plus c. Now if we want to turn that back into its root form, we've got 2 and square root, because that's 2 on the bottom, that means square root. 3x take 1 to the power of 3, all on 9 plus c. Okay, so we're almost to the end now. We're looking at another simple integral, this time an exponential with a base that is not e. So in this case, we're looking at 3 to the power of 2x over 2 ln 3 plus c. It doesn't really get much simpler than that. That's just following that base rule. So these two components here are, obviously the derivative of that bracket is 2, so we have to divide by 2. And because this base is not e, we're also dividing by ln of whatever the base is. Okay, so now it gets a little bit easier again. Now we're looking at integrals of resembling that 1 on x, or the derivative on the original function. In this one, we just have to take out that coefficient. So it becomes 2 integral of 1 on x dot dx. Integral of 1 on x, because 1 is a derivative of x, is simply going to be 2 ln x plus c. And then when we take this a little bit further, hopefully we can see that this is the original function. So this is our f of x, and this is the derivative of that original function. So if we find the derivative of x squared plus 3x, we get 2x plus 3. So if we can see that relationship, it's really simple. So we'll look at this as the integral of f dash of x over f of x, which will give us ln, absolute value of f of x plus c. And so in this case, we're looking at ln x squared plus 3x plus c. So it's a one-line integral. This next one's a little bit more complex, but we can still see that there's a relationship here. This here is the original function, so we can say that this is f of x, right? So f of x is x cubed plus 15x. F dash of x would therefore be 3x squared plus 15. Now you should be able to see that this is then 1/3 of f dash of x. So the easiest way to look at this question is realize that if we multiply this by 3, and because we don't want to change the value, we also divide by 3, then we get 1/3 of the integral of 3x squared plus 15 over x cubed plus 15x. So we've turned this into a special quotient. Will just be 1/3 ln of the original function x cubed plus 15x plus c. Okay, super simple. So that concludes this lesson. Again, it's just a bunch of examples. You will have to practice these skills and get to a point where you're fluent, because these are necessary skills for everything we build on when we go into the more complex forms of integral calculus.